All right, I wanted to add some clarification to the last video, specifically talking about this electronegativity. I know in the last video I talked about how your book uses values for it, and those aren't very important to us. It's kind of true, kind of not. What I would like us to do is not necessarily do the strict math that your book discusses, but we do want to look kind of at the values of the electronegativity. In particular for our polar bonds, is that the greater the difference in the electronegativities, the more polar the bond is. So if you think of this polar covalent bond as a tug-of-war, the stronger the person on one side than compared not to the other, the more that one side is going to pull. So it's going to be more polar in terms of pulling or attracting that electron towards it. Your book gives it's not a figure, but a table kind of depicting this. So I wanted to kind of look at that and discuss and show that what the symbols are, what they mean that your book uses. So your book looks at the electronegativity difference. 0 would be a covalent or a nonpolar covalent bond. And anytime that you have this 0, typically it's going to be between two elements of the exact same electronegativity. Okay, so electrons are shared equally. It's an equal tug-of-war. No one is winning, so it looks kind of like that. There's no distribution, there's no kind of hoarding of electrons from one atom to the other. Your book gives this value of 0.4 difference in electronegativity. Really, anytime you get away from a 0, you're starting to get into a polar covalent bond. Okay, now say a 0.1 difference in electronegativity versus a 1.5. Okay, that's what I'm talking about, a more polar bond. So as the difference gets greater, you get into a more polar bond. Okay, and eventually, okay, once we hit about a difference in electronegativity of 2 or more, then it's a complete, the tug-of-war game is over. Okay, the electron has gone from one atom to the other, and that's what we have defined as an ionic compound or an ionic bond. So going back to this polar covalent bond, this is where we have an unequal sharing of electrons. Okay, so the tug-of-war is still happening. They still have a rope in between the two atoms, but one side is winning while the other one is starting to lose. Okay, so now we have kind of this pull of electrons over to this right side. So we're getting a little bit more electrons over here, not so much over here. So we have a partial charge. Okay, it's not a full-on +1, -1 like it is over in the ionic. It's just a partial charge. We represent that with the symbol called delta. It's a Greek letter, and essentially it's an S with its curly Q that comes back around. So this is the delta minus, meaning it's a little bit more than neutral. The negative side is getting over to this side. If we have a negative side on this right side, that means we have a positive side over here, so we have a delta plus. These deltas are just representing that we have an unequal sharing of the electrons. And as we move from a difference in electronegativity of 0 up to 2, okay, the more polar the bond and the most extreme polar is the ionic bond. Okay.